Now that we have a better sense of what Wei is and how it relates to Ether, we can move on to talking about the gas system in Ethereum. The gas system is meant to measure how much work we are executing with our code. So think about the real world right now, or maybe just the world without Ethereum. If you write some amount of code and you want to deploy it to a server and have some remote server run your code, you have to pay money for that, right? Like if you want to run some code on AWS, Amazon Web Services, it's not free. You have to pay Amazon some amount of money to run your code for you. And so the same exact token is true in the world of Ethereum. In order to get someone else to run our contracts, we have to pay them money. This money is reflected in terms of gas. Anytime we send a transaction to the Ethereum network, there is some amount of gas price attached to it. And we'll talk about exactly what the gas property is. Before we do, I want to write an imaginary function into our contract right here, and we're going to review the function in terms of the amount of gas or cost that it would take to run. So at the bottom of my function, I'm going to add a new function called doMath. I'm going to call doMath with two integers, maybe an integer a and integer b. Remember that integers are simple numbers. An integer is going to be named a, and another one is going to be named b. Inside this function, I'm just going to do some arbitrary math operations. So I'm going to say a plus b. I'm not even going to try to assign this to any value or any variable. I'm just going to say a plus b. I'll do b minus a times b, and how about we'll say is a equal to 0. Okay, so not assigning these to anything, we're just doing the operation and nothing else. So I'm kind of curious now, what would it take to pay someone to run this code for us? We can break down the price of each of these operations with a little spreadsheet, and we can see exactly how much gas it would cost us to execute on the Ethereum network. So I've got a spreadsheet right here that tells us the price of some miscellaneous operations that we can execute in code. This is a public spreadsheet. You could do a Google search for it. The actual gas prices are really not relevant. You really just need to be aware that they exist. So don't really get bogged down in how much any given operation costs. Looking at the spreadsheet, you'll see in column G over here, we've got a description of some different operations that can be executed in our contract code. And then in column C, we can find the price in gas of each of those operations. So reading through the gas prices, in order to add two numbers together, we have to pay a price of 3 gas. To multiply two numbers, we have to pay 5. To subtract 2, we have to pay 3. And if we look down a little bit, I think right around here, to check to see if two values are equal, which we're doing as well inside of our doMath function, we have to spend 3 gas as well. So how does this gas actually get executed and applied to a transaction? And heck, what is gas really? Let's take a look at a diagram that's going to break down our function right here in terms of gas prices and get a better idea of how they work. All right, the first thing to be aware of is that whenever we issue a transaction that is meant to modify the blockchain in any fashion or run any code, we have to specify 2 properties inside of our transaction object. And we very briefly discussed these properties before, but we didn't really define them. The first property is gas price. This is the amount of Wei, or the amount of money that we are offering per unit of gas. So if I were to offer a gas price of 10, that means I'm willing to pay 10 times 3, so 10 Wei per unit of gas, in other words, 30 Wei, to add 2 numbers together. The other property is start gas, and you'll also see this very frequently referred to as gas limit in documentation. So these 2 terms are identical. We have start gas and gas limit, and you will see them used interchangeably. This reflects the total number of units of gas that we are willing to spend with this transaction. Now this is actually really important right here. It might seem like we're always going to know the amount of money or the amount of gas that we're going to need to spend ahead of time. Like we can very easily look at this series of operations right here, and we can go back over to that spreadsheet and say, oh yeah, it's going to be 3 plus 5 plus 3 plus 3. Okay, well clearly that's going to be 14. So we're only ever going to need 14 gas to run this function right here. However, there are many types of code that we can write where we cannot easily compute the amount of gas it's going to take ahead of time. For example, imagine if we run a for loop. What if we run a for loop over a collection of records that might grow or shrink over time? In that case, it would be much more challenging for you and I to just glance at some code and estimate how much gas would be consumed, because maybe we're going to run that for loop one time, or we might run it 100,000 times. And the difference between the two might be a tremendous amount of gas. So the purpose of gas limit right here is to say we are willing to pay at most this many units of gas to call this function. All right, so with these two properties in mind, let's imagine that we issue a transaction to run the doMath function. So let's imagine what would happen. Let's say that we issue a transaction and we provide a gas price of 300. So that means we are willing to spend 300 Wei per every unit of gas. And we are willing to spend at most 10 units of gas. So at most, don't spend more than 10. This is the absolute limit of what we're willing to do. So we would submit this transaction to the network. It would invoke our doMath function, and then all the lines of code inside of doMath would start to execute. First, we would run the addition function. Okay, that costs 3 gas. Then subtract. Okay, that's another 3. Multiply, that's 5. Equal two numbers, or equality of two numbers, excuse me, that's another 3. So in total, we would have needed 14 units of gas for that transaction. But we said that we were only willing to spend 10. So what happens in the case in which we say that we need some amount of gas, but we only allowed this amount right here? Well, for every operation that is executed inside of our contract, we execute a line of code or an operation, and then the person who is executing that code checks to see the current amount of gas that has been spent and how much is available. So in the case of our function right here, we would have a running tab that starts at 0. We would add 3. We would add 3 more to get 6. We would add 5 to that to get 11. And as soon as we execute more steps of gas than we have available, the execution of our function immediately halts. So right here, at this point, this is separating the difference between 6 gas and 11 gas. So as soon as we get to that 11, the person running our code would say, hey, there's not enough gas to cover this operation. We're done, peace, bye, we're out. And no other code is executed inside this function. So let's say that, well, maybe we recognize that ahead of time. Maybe we go back to our transaction and we say, you know what, I'm now willing to spend 20 gas. You can use up to 20 gas to execute the doMath function. So in this case, there's no problem. We only need 14 gas to execute the function, and we've said that we are willing to spend up to 20. So there would be 6 gas left over that does not get consumed, and that gets sent back to us, like you and me, the person who created the transaction object. So you only spend the gas that is actually consumed by the operations executed by your contract. Now, the last thing to do is to figure out how much money we would have spent in the case that we consumed 14 gas. So remember, we spent 14 gas, and we said that we were willing to spend 300 Wei for every unit of gas. So we would do a very simple calculation like this. We said we're willing to spend 300 per unit, and we used 14. So we say 300, that's 300 Wei for every unit of gas. We multiply times 14, the gas units drop out, and we're left with only 4,200 Wei. And that's how much money we had to spend to execute this transaction. The topic of gas, like I said, is going to come up every single time that we want to execute a transaction on the network. We also have to spend some amount of gas to store data within our contract as well. So just be aware that all these operations that modify or store data on the blockchain are going to cost some amount of money. Now in practice, it might not seem like the worst thing in the world, but in reality, well, things start to get a little bit rough. You can very quickly imagine that there are entire types of applications out there that you might want to build that start to get too expensive. Remember, whoever is creating the transaction is the one that has to pay the gas price. I want you to imagine for a second, maybe we'll go back to the Twitter example again. Maybe let's say you and I want to build a version of Twitter that operates on the Ethereum blockchain. Let's say that I'm a user of your application and I want to write a tweet to update my status. I am the person who wants to modify the data on the blockchain. When I submit this tweet right here, in theory, maybe we want to store the tweet on the blockchain. So I would be forced to pay some amount of money just to make a tweet. How often do you think people would use Twitter, or Facebook for that matter, or write emails if they had to pay for every message that they wanted to send out? Well, probably not that often. And so this imposes a very strict limit on the types of applications that you can expect to build with Ethereum, at least in my opinion. You're probably not going to find a common user out there who wants to spend like $1 just to update their status on Facebook, or $1 to like someone else's post. So this is a requirement on Ethereum that starts to kind of limit the scope of applications you can build. Nonetheless, there are a lot of ways to deal with this, and we'll talk about a lot of strategies of still making interesting applications that don't have to exert a lot of cost or money from your users. And that's something we'll talk about later on in the course. All right, so that's gas. Let's continue on to our next topic in the next video.